Hello everyone, let's solve question 37 of GATE CS1 2025 paper. A processor of has 64 general purpose register and 50 distinct instruction types. An instruction is encoded in 32 bits. What is the maximum number of bits that can be used to store the immediate operand for the given instruction? So the instruction is add R1/25. So this is a register and an immediate value. R1 is equal to R1 plus 25. Okay. So this is the given information to it. Let's approach this question step by step and understand what we have to do here. So the very first thing we require to know that we are given a processor has 64 general purpose registers and 50 distinct instruction types. Each instruction type is encoded in 32 bits. We are asked, what are the maximum number of bits that can be used for an immediate operand in this instruction? What is an immediate operand? So in an assembly language, let's say I'm writing add R1 and #25. That means R1 is a register operand and #25 is an immediate value operand, a constant value encoded directly into the instruction. Now, this is different from adding two different registers. So both operands are registered, it is not an immediate. So the question really is asking is, out of the 32 bits used to encode the entire instruction, how many bits can be reversed for a constant after allocating bits for opcode and register? अगर मैंने opcode और registers को bits allocate करूं, उसके बाद how many bits I need or can I need to reserve for a constant value. That means the immediate operand value. Okay. So let's understand what is an opcode. Opcode is basically bits that specify which instruction is being executed. Register field. These are the bits to specify source and destination register. Immediate values specify the bits that specify the constant value. This is what a typical instruction contains. So let's now calculate all of them one by one. So let's try with the opcodes. So we are given 50 distinct instruction types. Okay. So to encode 50 instructions type, how many bits do we need? So minimum number of bits, we need that 2 to the power x greater than equal to 50. So 2 to the power 5 is actually 32 and 2 to the power 6 is actually 64. So I can say this satisfies. So x can be placed here. So I can say that 6 bits are enough for the opcode because there are 50 instructions types now. So for each instruction type, we will take, so for all of them, I have to figure out how many bits do I need to allocate for the opcode, like the instruction I will be following, operation that is happening now. Register field. We are told that there are total 64 registers. Okay. There are total 64 registers. So 2 to the power 6 is equal to 64. That means each single register requires 6 bits. Each register required 6 bits. ऐसा question नहीं दिया. How many registers are involved in the instruction? That we need to figure out. Okay. So we know, let's first look at the particular instruction. So we are given add R1 and #25. So R1 will use one destination register and one immediate value. Okay. This is what it actually uses. So we need 6 bits to identify one register. Okay. As previously was just calculated that we need 6 bits to identify one register. Some instructions like add R1, R2, R3 would need 3 registers, 2 source and 1 destination. So if I write add R1, R2, R3, so this is working as a destination register. These are the two registers I'm adding, like on which the operations is happening. So we need total 3 registers. These are source registers and these are the destination registers. And obviously ALU and multiplexer is another thing. We are not going into that. So But in this case of immediate base instruction, fewer registers are involved. So 6 bits for register field are there because there is an immediate value, no? So I don't need to worry much. Zyada registers hai nahi. Let's try to figure out what are the immediate value bits. So let's try to maximize that value. So what is given to us? Total instruction length is 32 bits. Total instruction length given is 32 bits. So immediate bits कितनी होंगी? Immediate bits IB is equal to opcode bits 32 minus opcode bits. So 32 minus opcode bits minus register bits. So 32 minus 6 plus 6. So that is 32 minus 12, and that is total 20 bits is what I am getting. Okay. So this is what I can maximize for the immediate bits. So the maximum number of bits then can be used to store an immediate operand, as asked in the question, can be 20. So let's quickly summarize what we figure out, that there are 50 instruction types, 6 bits required per of them, 64 registers are there, so 6 bits to identify one register, and 6 bits for opcode. So for immediate 20 bits need to be required because total 32 bit is the length of the total instruction. So the answer is 20 bits. That's it for this particular question. Take care. Bye bye. See you guys in the next video.